Well, as Roman said, my name is Kachakil, and I'm here to introduce to you, to share with you some vulnerabilities that I found in the Android framework. Throughout the presentation, you will see that this is not targeted at those of us who are into looking the security of devices. If you are under users, you would be interested. If you are developers, you would be also interested. But even if none of these, you will be interested in the content of this presentation, and I hope that you like. Most likely you may know me because of my CTF's participation. I'm a member of Intrepids, but now I have, but considering the family responsibilities that most of the members have now, well, let us say that we are kind of on a standby point. And now I am a senior consultant of security in IO Active. In terms of my education, I have a degree in IT engineering. I have also followed a master's course in information system management and direction. And then, well, many of you would also know me from other activities. Other titles that came to mind for this presentation were the following. Because I didn't know how to title it, and I said, well, so much artificial intelligence, so much machine learning. Well, probably there will be a website generating a title for me, and that's exactly what I did. So 3 mistakes. Okay, you just type in the text, and because they are so smart, and they say, well, find and replace, and then, no, well, you just type in the content, and then it says 3 mistakes that make you look dumb. And I say, oh, this fits in with my presentation. Then cracking the Android download provider code, the ugly truth about Android download provider, an incredibly easy method that works for all, and then even you kids can do it. It's simple, and what everyone must know about Android download providing. So 17 tricks about Android download provider you wish you knew before. If Android download provider is so terrible, why don't statistics show it? There is big money in this. Yeah, well, if you find a bug, they pay you for that. And then the gold mine, the untapped gold mine that virtually no one knows about. This one I also like. Get rid of Android download provider. Okay, we start now with content providers. Those of you who don't know Android, take this as basics. So, to communicate with other apps, we have a content provider that may be connected to a database, to files, to the internet. At the end of the day, it's up to you. It is your code. You implement it as you wish. Often there is a database behind it and also some files. And then other apps will connect to the content provider and will use up that content. And how is that done? Well, very simply. From the viewpoint of the developer, I create a class that extends the content provider and the Android framework, and I see that there are a number of methods that we want to override. Insert, update, delete, query, the typical thing that we have in any data environment in general. Then we also, in the Android manifest, we get to see a number of sections that are to be declared within the manifest. There is a provider, we give a name to it, and this name is the name of the class. Then authorities will be a unique name that we will refer to when it will come to access the content provider. We will have to specify that name to access to the content provider, and then whether it has been exported or not. In very old versions of Android, whenever the API is below 17, everything was exported by default. As of API 17, now you have to write exported true for other apps to access to our content provider. You can access to a content content provider so that you consume it in your own app, but that is not necessary. So the good thing of having a content provider is that other apps use our data service. And how is that implemented? So we create a new class that extends or inherits from content provider, and we implement it from there. This comes from the documentation of developer website, developer.android.com. So we do a URI matcher, which is a component that will interpret the URIs, because you access to it through content, // name of the provider, etc. So in this case, we define the static initializer of the class, a couple of URIs. So there are two examples here where we have the provider, and then we had /, in this case table 3, and then there is another one which is a pad. So this means that it is a number identifier. So when someone in Android app access to content // content provider, and then the match that we want, it will return a constant, a value. In this case, either 1 or 2. So 1 for the first case, 2 for the second case. Then we implement the method to launch a query. So there are a number of parameters, the actual URI that was requested, and then projections, selection, arguments, whether we want to sort data or not. And then the typical code that we will see will be a switch or something similar to that, and say, let us see what the URI matcher has returned. It has matched it against the value that I have specified, number 1. If it's number 1, I do this. If it's number 2, I will do that. If it is none of the 2, out. You have specified something that I have not defined before. How is this used from the other perspective? So we have created the content provider. How does other apps consume this data? For instance, in query, we have a content resolver, and then we invoke the method. We specify the URI, content // etc. Then other parameters in this case are left null. That will be the projection, will be count column 1, column 2, selection, which will be the actual web, where C3 value is this, C4 value is this. What is that? This and that. Okay. Next, in selection, we have the argument. We just include right of the screen, and then sort. Okay. Ascending order as of column 5. So this is for you to see the equivalence with SQL Classic. Update, for updating of register. Give me the content resolver, I tell you the URI that I want you to update for me, and these are the values that I'd like you to use. Of course, we will be including some filters, otherwise it will update it all. Delete these, you had in content URI, and then HDB. So you enable the debug mode, say content query, this is the URI, and this is also another way of invoking. This is not the usual one, but it is good for us to test things, to try out things. ADB, when you launch a shell, it is executed through the shell user. Not in all cases, whatever uses from the shell user will work in the same way with another user. So bear that in mind. You may go and say, well, this is a failure, yes, but you are also enabling debugging services. And as for the rest, that will depend on the permissions that your application may have. The good thing about this is that you gain access to the source code. So I will tell you about, well, both of them. The first one is a quick introduction. The second one is the actual content. Where can you get the code from? GoogleSource.com, then platform, packages, etc. And in this case, within the provider's root, we'll also ask it to download provider. There is also a mirror of this repository in GitHub. But as they very rightly say, this mirror provides a read-only mirror of some of the most common repositories. So we have that of the download provider, but we don't have that of the user dictionary provider. So my recommendation is ignore GitHub, and if you want any repository, you just download it from the Android source. What is the user dictionary content provider? Well, a few months ago, we published in the blog of IO Active how I came across this vulnerability. We had a project with a client, sent in the telephone number and said, please audit this for me. And I said, what is this? And I said, well, the full telephone number. And I said, well, where shall I start? And then from our lack of experience, we asked those who knew more than we did. And I said, what do? You do this and that, and then, well, you take a look at what returns to you. And I said, look, I'm not very motivated to do that. And I decided to do it my own way. And then I said, well, APK translation to source code for Java is quite well. Then Java code, I read it, understand it, and I see what comes out of it. I started to look into that. But the APK that were signed from Google, and say, I'm not going to make the client pay for something that will be audited in the Google app. So there was something here was not signed by Google, and I took a look at it. Then, basis, starting points. You don't really need to know about programming. This is an all public presentation. So we will start from the scratch, okay, from the basics. I don't know whether you are aware of it. Scratch is a programming platform for young kids. You give them blocks, and then it executes things and does things for you. This is an example. Applied to our world, if the username contains a name, then you say hello. Well, we all get that, isn't it? Well, I'll give you another example. They say hello, and then you check whether the username contains a name. And then, in that case, no matter what the user contains, you say hello. Well, with that, we already have a vulnerability. You don't really need to know more than that. This has been already published. I'm not going to tell you, but it's been already published. Okay, take it as a way of introduction. This was the code. Well, the user dictionary is that of the Android keyboard. When you type in a strange word or something that is not included in the dictionary, you may add it to the default dictionary. I don't know, your family name, the name of your company, name of drugs or medicines, and this is the code to update the dictionary. Open the database, you update it with the term, and then it says only the enabled IME input method of entry can access to this provider. And then I say, okay, come on. So then update, and then they tell me whether I can have access or not. This is kind of the other way around. So the same goes for delete. Then I delete, and then I can gain access, and I say, look, but I have already deleted. So it's just, again, the other way around. So user dictionary provider is the first example that you find in the documentation. If you want to know how to develop it, it will be the first one that you will find in the Google documentation, surely. Well, many people have already looked into it, have worked with it. As you can see, it's being exported. So I made a small proof of concept Then it took me 5 days. So in this case, I created a dictionary, 1, 2, 3, because the code that I wrote only updates or deletes the entries starting with 1, 2, 3. Well, because I already demolished or ruined my dictionary with the testing. And I said, well, please ensure that you do not delete your dictionary. Okay, so this is the update of the record. All entries starting off with 1, 2, 3 will be deleted. And then the other button is there. And well, this, as I said, this has been published quite some time ago. I'm sure that many of you know it. And then I wonder, I ask myself, I can delete, I can update, but someone may be interested in knowing what there is, or what I have in that dictionary. And then I thought about the following. I set up or developed an application that updates any number of times the same record. It also measures the time, and if that register exists and says update this value, okay, replace this with that, then look for that ID1, block the database, and at the end does not update anything, but that takes longer. Then by simply taking a look at how long it takes to update, with the update, by making queries, those queries that do not change the database, and by measuring the times, we will have an engine that we will be execute over and over. So it says, well, the first letter ID, you do it, and if it starts off with A, it will take longer, with different letter, it will take shorter. So this is a way of exploiting a side channel that allowed me to obtain that information. That was reported to Google and say, yes, it's a vulnerability, they corrected it, or a failure, they corrected it, and that was it. That was the end of the story. And because I'm not here to tell you about that content provider, but download provider, let us go for it now. Those of you who had an Android with a mobile phone or a tablet, anything that you do is being pointed out by this arrow, pointing out notification. This is the download provider. Download provider, download administration. It has been given different names in different versions. This comes from the documentation that I may find in the repository. It is quite an old HTML. If I have some time at the end of my presentation, I will briefly show it to you, because it is like Android archaeology. So they mention version 1 and says Gmail Market. So the idea is that I have a download provider, a number of apps. I have the viewer of the downloads, so we can see what we have already downloaded, and then I have a firmware. But this is as much as you need to know. So I downloaded, returned the URL content provider, but we are not interested in that. So the download provider is supported by a database, Seculite, and basically comes in with two tables. Table for the downloads, which comes in with number of columns. We are not going to go into detail, but basically it has the ID, the URI, the method, and it has another one for the headers, where we correlate the ID with the ID download. And then we have two other tables for Android metadata and then the SQLite sequence. This is an example of what you may find in this type of tables. So this is the download table, as I say. We have a header, description, URL, the site or the address or the storage site, and this is the request headers. What about the manifest of this provider? Basically, we have three things here. My downloads, that is to say the app that has requested a download can access its own downloads. For that, we need the internet permission. Then we have all the downloads, and here we need the permission to access all downloads that has only been assigned to the actual Android. And this is verified through signature, so if you are not Android or the manufacturer, you will not have access to downloads. And then backward compatibility, because in the past it was not my downloads by dash downloads, which is exactly the same as my downloads. Then it comes in with a couple of values to be allotted. You may grant permission, but we are not going to go into that. And then the URI matcher. When I introduce URI, it verifies for me whether it is included in my provider or not. Then the number of constants have been described here. My downloads, my all downloads ID. Then we also have a segment which is later on added to other URIs, that is for the headers, and then we also have public downloads and ID. This is the way it shows in the code, and if we replace the constants, this is what you get: my downloads ID, all downloads ID, etc. Now let us go into evaluating the code a bit more. I don't know whether you are aware of José Bono, not the actual politician, but the human calculator. So he basically does that. Well, if you've been developing for many years, you kind of develop some skills, okay, to get the code and to say, look, this is wrong, to spot an error. So let us take a look at the query method, which is the one that helps us with the download. Let us read through it. It is, you don't really need to have lots of knowledge to understand it. There is a database, a reading mode, then it matches the URI, then it also has a number of logs. We will not be interested in that. If it matches the headers, we do something, and then this is the second part of the method now. Get where clause. The detail of this function shows here. That's a number of checks, and then this one should restrict visibility. If I have to restrict the visibility, basically for projection, if a number of queries that are protected or protected columns are queried, it will check them, okay? And these columns, protected columns, are defined in here in this list. So it goes all the way top down. If I don't have to restrict the visibility, I write in the log, we execute access database, we launch the query, and then again code. So that is the query side. So this is what I refer to vulnerability number one. In the code we've just seen, that's what we have all the vulnerabilities. And my question is, what about public downloads? Well, they have been defined, my downloads, all my downloads. But here in the URI matcher, we have a public downloads. And then we also have an ID, a number. What is the permission that protects that? So that is the question. What are public downloads about? What happens if I do this? If I do ADB shell and I ask it to give me URI content number 1 and 2 and 3 and all the downloads, well, you more or less can guess it, isn't it? That method doesn't have any permission and there is nothing in the code. Well, there is a column in the database that that doesn't show in the code at all. And what happens when the URI matches it with public download? So basically, it gets in through here, then we access the database, get request URI headers? No, it wouldn't go through there. Okay, here, in the get work clause, yes, it will go there. It will go there and say, if the URI matches this with my downloads ID, no. Oh, and now public downloads, yes, here it will. So, in your where, in your selection, I would say ID should equal the question mark. Question mark is the value that we have given to it, 1, 2, 3. Here it says, match it with all my downloads? No. Okay, I wouldn't go there. So therefore, it returns the selection. Then, should I restrict visibility or not? Well, even if you restrict it, the projection will be a number of columns. Even so, I will get columns for a download which is not mine, and that's where the problem is. And again, more of the same. That's the log, it executes the query, and then it returns what we have asked it, that is to say, all downloads. So basically, this failure allows you with an app that you may install in your device, which is a significant entry barrier, but with no permission whatsoever. It goes through ID 1 to any other ID, and you can compromise every single download. What you are returning is number of columns, number of data, then when you have the title, description, etc. But what we are actually interested in is, well, here also the actual file. Could we access the file? Well, this vulnerability, we refer to it as permission bypass. Actually, you have given me public download, okay, there you go. Everything is public. There is no actual code checking whether that is a public download or not. So therefore, access to all downloads. So that is the first vulnerability that we have spotted. What did I do here? I developed an app, very cool one.
You hit the button and it basically spits out the information. Then I added a couple more things, a function that overrides files, and then it starts up a service. We will see what it's about. And then there's an option that closes or does not close the files. Remember I was saying that it has a content provider, has a query, etc. But in the most recent versions, there's an open file, and this open file is given by the provider. What does this allow you to do? It gives us a file descriptor directly with the access to reading and writing. So, how does the open file validate whether we have access or not? This is protected by query. As query is vulnerable, there you got it. We can access not only the details of the file, we can read and write the file. We don't need any authorization or writing in external storage or reading, no permission at all. So this affects ancient versions. I haven't done any archaeological research, but it works as from version 9, I believe he said. The second part of the open file, as I was saying, the open-close file, the second part of that, when you open the file in read mode, in write mode, sorry, if you modify any property of the file, the database is updated, and there's a event handler that detects the closure, and that executes the code which invokes the update and says, okay, file has changed. The problem is that the update was not vulnerable to this because you can't do the update with the download. So that code will launch an exception that will trigger the download supplier that will close and will restart automatically. But we will see a notification that says that this process has closed. What can we do with this vulnerability? Well, I show you a few demos by way of example. The rest is up to your imagination. If I have my Gmail application, this is our service, and I said, okay, spit out the information, returns nothing. I open my email, I have an attachment, I download it. You see how it is downloading the attached? I click again, and there we have all the info. The ID of the download, the URL that could have data access tokens, etc. So here you have the content of the file, everything basically. Once the download is completed, the place where the file is saved. Total access. If somebody gives us an application like this one, we would have that description there, and we've just seen whatever I introduced. So I have an important resource for information. Not only the file, but who sent the file, who sent the email, a lot of data. With something as silly as getting public download one. Another one. What happens if I go to a Play Store and I download an app? More of the same. We come here, we run the service. So I download this Google app, I install it, permissions, whatever. Hey, look, the download supplier again. We can do without download whatever we like with it. But probably the other PK, the malicious PK, so potentially the app will verify a file and check signatures, etc. So as you can see, the file is downloading, so the service is running in the background, and it sees there's a failure, it retries, we bash it again, it retries, so it gets to a point where the app gives up. There it is. If we have this malicious app, we can prevent anything being installed, or we can select which apps we don't want to be installed. And here, okay, we kill the service, and you see the error. That is because the descriptor was closed. So then you update the file. So what happens when you update apps? It's the same thing. I start the service, I go to the Play Store app. Here we have the installed apps. So I go to update Gmail, whatever. You download it. There's an APK file, you bash it again, it tries again, you bash it again, etc. So the user is unable to download the app. This for parental control is great, actually. You can't download or update anything. And the updates of the OpSys and the Android apps that come on OTA mode, they are under the download supplier. So if Google patches it, and if you have the app running, it won't allow you to update not even the operative system. It won't let you to update not even the operative system. So it's a big, big failure. Here we see the update continues to download. This is a bit fast view, but you get to a point where it gives up. We have the error, unable to update. So we hit the message to see the details, and this is what we get. Can't update because we're just bashing the file. Let's see another thing that can be done with this. Well, someone sent us a mail with a PDF attachment. We get the preliminary view. There it is. We go to the file where it was downloaded. We'll repeat the same action, but this time with our ordinary download service. The service has a sort of a switch, looks at the extension and says, okay, if it's a PDA, it does one thing. If it's an APK, it does another thing. We get into Gmail, we download it, the same email, we open the attachment. The preliminary view is still not updated, so I open the file and there we get, this is what we got. So we can replace the file with whatever we like. If someone sends, is this your payroll? Apart from filtering it, of course, that file we can read it, write it, do whatever we like. Another example, more of the same, it's an image. You go in there, you run the service, and this is a different app, Google Chrome. Who uses Chrome in Android? Nobody downloads anything. Well, here we download the Google logo, we open it, there we got it. As you can see, we stop the service, we send the app. This is the error that will trigger during the update. The exploit keeps the file open and it just keeps it. So it's not an error for it being so direct. So this is how it is. This is more of the same with Gmail. From the, we can download from the bank. As I sent these videos to Google, so that they could see that even your own files were affected. It is not serving a different file. So how can we correct the second vulnerability? There's many public downloads of which you can't do anything. The second vulnerability, the same code. Here we have the update and the delete. You see there is a validate selection and a number of safety measures. There's a check as well. These are the columns that allows you to read. And these, there are some columns that you can't read. There's some cookies. There's a column there that they regard as sensitive, and you don't have access unless you have the straight permission. But this mobile is interesting because you can do a DD pool without doing a root. The applications are APK, so you can download this to your mobile, either Android or any other, and you can make a number of different modifications. You take the mobile, you take the PK, you decompile it, and you say, look, here I got a select because it's not within the master file. This is a validate selection. Basically, it verifies a lecture that matches whether the columns that you specified are from the supplier. This should be effective, but there is a commit somewhere of 2016 and someone said, I'm going to enable search in the download provider. Makes a commit with this. It ruins it eliminates the validate selection and adds a number of things that set strip. We'll see later on what this is about, and it just modifies the query a little. The problem is that eliminates the verifier of downloads. the validate selection is rendered useless, but then this commit has this unitary test that you can see whether this is safe against a malicious selection. And the developer injects something saying, look, I put this 1 + 1 order by, etc. If there's an exception, well, this fulfills its purpose. The problem is why the exception arises. If you have this order by thing, you can test this with ADB, and what we executed was the where of the unit test, and we will get this mistake. But this mistake, there are 4 brackets that open, 1 that closes, so you have a syntax error in the order. If you open 4 and close 3, you will get an exception. So if we check this up, you'll see, yes, you run it, and that's it. So, as there's a bracket missing, we'll just close it. So then we'll try this. I'll put the parenthesis that was missing in the unitary test to say, well, this should have been this way. And the error we get is here. Now we open 3 parentheses, now we open 3. This is, you must be joking, sort of thing. So, testing, I look at something else, and it's exactly the same as the top, but instead of putting an order by and a column, it's put a non-existent column. Now it opens 4, closes 4, so it's okay, it's nearly ready, and then it puts a parenthesis at the end of everything. So, oh, it's going crazy, and what is this about? And this is the set stream, which is a safety measure, so you don't try tricks. So then I said, okay, let's start the easy way. The vulnerability number 2, you can imagine it how what nickname I gave it. So what happens if you do this? And now we include this as where. So this returns absolutely all the downloads. Something as simple as this, that's a vulnerability. You don't need to have a lot of experience. So, when little is ID is equals 1, can start the weight, B, etc. So then I can get information of the columns which you could not access, and with this we can get more information. So we could write the file, read the file. Now also the columns are protected, and we have access to this. So if we can make a subselect and we go to the other table with a header, more of the same. We can extract an entire database. If you remember the code in which we entered basically the get where close, we came in through here, and then the ID downloads where ID equals the ID that we specify. So this will form the chain from the right. Then there's an AND, so which has priority, the AND has priority. So we will take a look at this. The work that we have done is we have or 1 equals 1, or, and there is no ID equals 0, so this would give false. And then we have this, true and our condition, or true and false. So our condition, because true is the condition and true and false is false, so with this we can inject whatever we like. So once that Google accepts it and patches it, I look at the patch, see, well, they've been touching a file here, totally unrelated to the download supplier. This is the framework. So the set streak can be used for adding security, but unfortunately it won't take injections as silly as 1 equals 1, parentheses, etc. So not only I found a failure in the download supply, but in the set streak, and I didn't know anything about it. So this will give more security to the download supplier. And this is the third vulnerability, which is related to request headers. Downloads have headers and values. Here we have, by way of reminder, the manifest. Here we see that in the My Downloads, we need the internet permission. Now we finally need a permission, which is the internet permission, and it's like a given. In the URL matcher, here we have all the downloads. We can forget about all downloads because we will never get that permission. We will analyze here the query, goes in through there, does the match, writes the log, then it says the match is a header. It is, right? So when the selection is nil and then navigation is nil, there is no other parameter except ID, then it will invocate the query, which is the function we have here. And the function we have at the top is the URL, is the one I will give it. And the projection is, here we have the header and the value, the only 2 columns of the table. So then my downloads, who validated this as being my downloads? This is more of the same. What happens if I do this? My downloads 1, 2, 3 headers, etc. until you get bored. So basically we have access to each and every one of the key pairs, header, name, header, value of all the devices. What does this table have? The exploit is a very silly code like this one. We can put any number and value here. We access this content supply and we do /my downloads / the value and the segment, and we show it. So we have a bypass of permissions, so we haven't really done anything. It's a functionality that in Android has given us. If you think these are downloads, okay, whatever you say, nobody's doing anything wrong. What can we do with this? This is recorded on an old version, so I had it handy. So in the old browser, because this doesn't happen with Google Chrome, here we'll access a simulated intranet. Imagine you're in your office, you're one of these top secret download suppliers with lots of security. You enter your user and password and user, and there you download your authenticated file. So let's forget about the rest. You simply download the file, you get this, and you said, hey, so not only you can access the downloads, you can impersonate the user. So the failures are really so stupid that it is shocking. How has this been there for years? And it is affecting millions of devices, which many of them haven't been patched. And if they have, the manufacturer has applied a patch, and there's an application that is bug in it and it can be updated, well, the failures are considerable. Conclusions. Detect failures in the code. Well, it is easy. A letter without an accent, or a letter, or a word without a letter. So what we have seen is missing code failures. It's content that is missing. It should be there. And this is so obvious. Because if it were obvious, they would have resolved it. A couple of suppliers I was checking out. I started to look at suppliers. I found the 3 failures in 3 hours. So then we don't have to be afraid saying that Android is totally checked. And if it's not only Android, it's any other app, any other program, it's a methodology that if you apply common sense to it and you look a bit out of the box, what the code does, but what I can do with the 3 elements I have, the manifest, the download suppliers, and the APK. And if I just ask these 3 questions, it's a worthwhile methodology. Of course, you can't publish everything here because a project that no one paid us for it, a research product. I never worked on investigation, but if I get down to it, I thought it would be good. So I was commenting this with a friend who was in a small town in Germany. I showed it to him and I said, "This can't be. This is unbelievable." So I bet that anyone can get data in this way. So then he came to see me with a laptop and said, no, don't bring work to the dinner. So I want you to check this, he said. So I found a failure here, an identical failure, another download supplier, and he said, this is a stupid thing. He reported it as low risk, and Google said, this is a high risk. So I said, well, could be. That evening, the guy went back, he downloads the contact app, and it says, hey, again, the contact agency is totally exposed, the photographs, telephone numbers, everything exposed. So it's not a question of luck. The code is a bit catastrophic. It's really easy to put your foot in it. When you're checking code, there's a dip, line, it looks good. But take a step back and look at it in context. This will give you the different view, and you will find these things you'll find many failures. It's a project that is in ongoing updating, and simply by reading the code, which is extremely simple, how much do you have to know about Android to do this? Nothing, basically. Millions of Android devices continue to be vulnerable to these failures. Many of them do not have support. This affects many versions, so when you're downloading anything through your mobile, think about it. Watch the apps you download. Some of it could have been exploiting this for a long time. And also from the developer viewpoint, if you develop don't trust the file that you have downloaded. Validate it in some way with signatures, because you can have certificate pinning, etc. It's not reliable. It's not like I have a rooted telephone. Any app could be doing this. And that's all I had to tell you. So thank you for listening to me. Thank you Rooted for bringing me here. And I'd love to I'll be happy to answer questions. So just let me comment that the exploits I showed you will be released. They're in the hub, they're still private, but between today and tomorrow we will publish them, and shortly next weeks the advisories will be published with more technical content. Thank you, Danny. You know the routine. Come to the mic if you want to ask questions. I have a statement question for you. I always fight with the Talibans of the open source that you don't have guarantee that a code is safer just because it's open. We have seen that we just have the code, and that code is in 8,000 repos that anyone could have downloaded in the 8 years it was there. So any manufacturer take the ES base will adapt to the needs, and the base, who's going to touch the download manager? It's incredible. Any question? Okay, so thank you very much, Danny.